Sir, our topic is agent navigation in maze using TD reinforcement learning. So, our group members are ABHIRAM, myself, AMALKRISHNA, and Vaishnav. Then going to the abstract, we are using the reinforcement learning, which is a machine learning technique for solving problems by a feedback system applied on an agent which operates in an environment and needs to move through a series of states in order to reach a predefined final state. So the this learning complex task through reinforcement learning can be time consuming. Um, Going to the introduction, the environment for this problem in a maze is with the walls and a single exit. Here an agent is placed somewhere in the maze. The goal of the agent is to reach the exit as quickly as possible. To get there, the agent moves through a maze in a succession of steps. For each step, the agent must decide an action to take. The options here for the agent is to take the left, right, or up and down directions. For this purpose, the agent is trained and it is learned a policy called Q learning, which tells what is the best next move to take. With every step, the agent incurs a penalty, or when finally reaching the exit, a reward is generated. These penalties and the reward are the input when training the policy. The policies used here are based on the SARSA and the Q learning. During training, the learning algorithm updates the action value function Q for each stage which is visited is being noted. The most probable action is indicated by the highest value. Updating these values is based on the reward and the penalty incurred after the action that was taken. Then, with the TD learning, a model learns at various steps to take, and not only when the exit is reached. However, it does a speed up once and exit has been reached for the first time. Then for next slide is taken by Amal Krishna.
Hello, sir. I'm Amal. Coming to the background of our project, we need to have a clear understanding on what is reinforcement learning. So, reinforcement learning is a subfield of machine learning that deals with the decision making in dynamic and uncertain environments. So, it is an important area of machine learning where an agent learns from the environment by interacting with it and receiving rewards for its action. So, reinforcement learning involves an agent interacting with an environment and learning through a trial and error process to make sequential decisions in order to maximize a numerical reward signal. In reinforcement learning, decision makers observe the environment, take action based on their observation, and receive rewards from the environment. Reinforcement learning differs from supervised learning, where the correct answers for actions are known, and from unsupervised learning, which focuses on discovering patterns and outliers in data. So, in reinforcement learning, the agent learn, as we discussed, the agent learns through the exploration and exploitation. It explores the environment by taking action and receives feedback in the form of rewards or penalties. Based on this feedback, the agent updates its knowledge and refines its decision-making policy. The goal is to find an optimal policy that maximizes the cumulative rewards over time. So the key features of RL is learning through reward signal with the goal of maximizing overall reward by improvising the agent strategy. The RL system learns the mapping from environment to its action. RL is often based on frameworks of Markov decision process, which is defined by four components: state space, action space, state transition probability, and reward function. Coming to the next slide, we have a maze map here in our project. A maze map is a graphical description of a maze, which is a puzzle-like structure consisting of a passenger walk or one or more goals. The goal of a maze is typically to navigate from a designated starting point to a goal by finding path through passengers while avoiding the wall. So in our maze map has a total of 25 states from S0 to S24. S0 is the start state and S24 is the goal state. The direction of the movement of the maze can be divided into four directions: up, right, down, and left. The outer frame line and the inner straight line are walls, and the maze cannot pass through it. The next slide will be explained by Abhiram.
So I'm here to give a brief description about the algorithms that we used. So basically, there are two classes. Uh, the first one is the environment class, and the second one is the TDA agent. So those two classes are used in the main function to allow the TDA reinforcement learning algorithm to take place. So the main function takes the following parameters. So first one is the num episodes, that is number of episodes for updating the policy. Next is alpha, which is the given weight to the TD error to update the policy online. So next is the discount factor for the future state action reward. Then comes the epsilon, which is the probability of making a random action in the training using the epsilon greedy approach. So the next one is import maze CSV. So when it's true, it imports an example maze from a .csv file. So next one is show training. So when this is true, it shows the training steps that the agent make for every episode till the end of all episodes. So it is useful to visualize the improvement of the agent between the episodes. So the next slide, it's about the training. So the after the instantiation of environment and TDA agent objects, a training phase is started. So first the policy is initialized with random values. Then a for loop cycles each episode, where the start of them, the state of agent is set to the initial state 0. Then the following loop is implemented, like given the state, an action A is selected using the greedy policy. Then the selected action A, we perform the action in environment and compute the reward R. Then the next state S dash and the over flag. So after that, the policy matrix is updated. So then it is repeated until the episode terminates. That's it. So the next slide will be explained by Vaishnav.
Sir, myself Vaishnav. When the training process is complete, the algorithm shows the results by printing a version of the maze that reflects the learned policy. This means that maze is displayed with the optimal actions the agent should take from each state to reach the particular goal. The policy is typically represented as arrows or symbols that indicates the direction of agent should move in each state. Once the maze is learned with the policy is printed, the user is promoted to press an enter option. And coming to the implementation part, when we press the enter button, a small simulation loop begins. In this simulation, the agent follows the learned greedy policy denoted by Q, S, A to navigate through the maze and reach the end. During this simulation, the algorithm visually demonstrates how the agent moves by step, following the actions dictated by the learned policy. The agent's position is updated based on the policy, and the process continues until the agent reaches its goal. The algorithm mentions that the TD reinforcement learning algorithm was tested using custom maze loaded in a labyrinth CSV file. This indicates that the algorithm supports using different maze configuration by importing them from external files. Overall, after training, the algorithm visually presents the learned policy on the maze, performs a simulation of agent following to the policy. When we run the code, it shows a policy that have showing the environment of the maze. When we press the enter, the maze start to find the optimal final position. The algorithm also mentions the capability to import custom mazes from CSV files for testing and experimental purposes. That's all. Thank you, sir.